In this video, we will be answering some problems on indefinite integrals. This is a worksheet coming from Kuta software, um, particularly in the chapter of infinite precalculus. So yeah, we'll be answering them. In everything, there is one technique that we're supposed to apply. That's basically the opposite of finding the derivative of something. We all know that, let's say, a is equal to something, the derivative sign would indicate as this one, a prime, or, well, yes, just a prime. Let's say if it's f of x, then the derivative would indicate that it's going to be f prime, f of x prime. But then in this lesson, evaluating indefinite integrals, we use certain rules. In particular, if we have anything that has a constant, this is, I'll just break it easily. This is power rule. So if you're given something like this, this is the integral sign, by the way, x raised to n. The power rule, you just do this, x raised to n plus 1 over n plus 1. And that should give you the antiderivative, I think. Basically the answer after evaluating each indefinite integral. So let's apply this rule. So for number 1, we're given 30x raised to 5. So 30x raised to 5. Basically our n is 5, and then we place plus 1. And then we divide by 5 plus 1. That should give us 30x raised to 6 over 6. We could further simplify this. It basically becomes, sorry, it's going to be 5x raised to 6. I'm sorry if I cough often. I'm not really feeling well, but yeah, I still made this video. 5x raised to 6. So that we don't have to write this anymore. By the way, this is the answer. And there's also a policy in evaluating indefinite integrals. Using this method, using certain rules, or I'll say this in advance, you something called U substitution. We always put in our final answer a plus C. Otherwise, you won't get much credit when the teacher checks it. I'm not sure exactly why we have to place plus C every time, but yeah, it's always important to place a plus C, regardless. Unless if you're trying to evaluate what we call definite integrals. In this case, you'll be getting a number as an answer, an actual integer, instead of an expression like this. Therefore, you don't need to put plus C. Let's move to number 2. 24x raised to 5 dx. So power rule, 5 plus 1 and over 5 plus 1. It's going to be 24x raised to 6 over 6, and then 4x raised to 6. And then don't forget to place plus C. That's it. Number 3. Now, we're not given any exponent. Actually, there technically is an exponent, but as a rule of exponent says, we don't exactly see it, but any number will always have something that's raised to 1. Well, it will always be raised to 1, because example, 4 raised to 1 is still equal to 4. So there's basically an invisible 1. So if you're given any constant, there's this rule called, I'm not exactly sure what this is called, but then say you're given a number 1. If you integrate this, it becomes x plus c. You basically write this as standard, and then because it's just 1, so 1 times x is still whatever that x value is. So we don't have to write 1 anymore. For let's say we have 2. finding the integral of this is 2x plus c. So we still copy x plus c as standard 2 because the initial number is 2. Let's say, I hope you're getting the pattern. Let's say we have 45. Finding the integral of this is 45x plus c. So yeah, that's it that you have to take note of. So in the context of our situation, we just put negative 3x plus c. I believe this is the answer. Double check, let's check the answer key below. As you can see here, it's exactly the same. Negative 3x plus c. I think I remember now what this thingy is called. I think it's called the constant rule. But I don't know how to express it in this kind of form as per the power rule. Like just like the power rule a while ago. So yeah, but the idea is easy. Let's move to number 4. 15x raised to 2. What do you call this? Power rule. So we write something like this, and then 15x raised to 3 over 3. That's gonna equate to 5x raised to 3. And then don't forget plus c. Okay, that's it. Number 5. Okay, we're given more than one term in this problem. We have two terms, 12x raised to 5 and negative 6x. Or we just say minus 6x. We basically distribute the integral sign in each term. That's what you have to do if you're if you meet this kind of problem, and then apply whatever rule is appropriate in order to find its integral. So 2x raised to 5, and then plus 1, and then 5 plus 1, and then the other term we have an invisible raised to 1, because 6x raised to 1 is still equal to 6x. So that's the logic of it. So 6x raised to 1, we always put plus 1. Following the rule, there is n plus 1 in the exponent as well as in the denominator. So n plus 1 is still 1 plus 1, 1 plus 1 in the denominator. I'm not sure though, I think it's debated, or I'm just a little more ignorant in my class. But yeah, I'm not sure if you're supposed to put integral signs at this point, but yeah. Please correct me if I'm wrong. I just learned this lesson a few weeks ago. 12x raised to 6 over 6, and then minus 6x raised to 2 over 2. Certainly, you don't have to put an integral sign here anymore. So 2x raised to 6 minus 3x raised to 2. I think this is the answer already, and then place a plus c. Let's double check if you have the same answer as the answer key. Exactly the same. Okay, let's move to 20. Let's move to 6. 20x raised to 3 plus 4x. Here, 20x raised to 3, you put plus 1 in the exponent, and then you copy the exponent and the denominator, and power rule in the second term. And then we have 20x raised to 4 over 4 plus 4x raised to 2 over 2. 5x raised to 4, and then 2x raised to 2, and then we put plus c. That's the final answer. Let's see if I got it right. Exactly the same. Bueno. Okay. 12x raised to 5 and then minus 4x. Distribute the integral signs again, and then power rule. Then simplify. 12 over 6, that becomes 2. And then 4 over 2, that becomes 2 also. And then we put plus c. Boom. Finished. How about number 8? We have 24x raised to 5, then plus 1. This is the easiest of, when you see this, it's really easy to solve. You just put x plus c. This is the constant rule to recall. And for the first term, we have 24x raised to 5 and then plus 1, and then over 5 plus 1. But for the it's not exactly mandatory, but then I just keep it this way for now, just to respect the time that it takes to solve for the first term. But yeah, we'll eventually write x plus c later, once this one is simplified already. So 24x raised to 6 over 6, and then we put plus x plus c. I hope you get my point. But any way could do, as long as it follows the rules of math. So 6 over 15 is 24, it's 4, and then finished. Okay. Let's see if we got it right. 4 x raised to 6 plus x plus c, the same. How about number 7, 2x raised to 6 minus 2x raised to 2 plus c, the same also. Okay, let's try this critical thinking question. Oh, interesting. So this is basically, this expression is already the integral of something. We're just basically tasked to find the derivative. I can't really guarantee you a correct answer, but I'll still give it a try. Derivative is written as d over dx. So, let's try. Derivative, the policy is 6 times 2, that makes 12, and then minus 1. 6 minus 1 is 5. Same thing as with the second term, so 2 times 2. Multiply the exponent and the coefficient, the base coefficient with 4, and then, with 2. Multiply them together, and then exponent will be subtracted with 1, so that makes 1. What do you think? 12x raised to 5 minus 4x. Yeah, this is the answer already. Actually, my teacher told me, this really intelligent teacher, she told me that there's one way to check if your answer for finding the indefinite integral is correct. So let's say you're given this kind of expression and you want to find its integral. So let's say 12x raised to 5 and then plus 1 over 5 plus 1. Yeah, you're tasked to find the integral. So you're given something like this, and then minus 4x. It's gonna be still the same, power rule, and then x raised to 6, 12x raised to 6 over 6 minus 4x raised to 2 over 2. If you simplify that, 2x raised to 6 minus 2x raised to 2, and then you put plus c, right? That's our policy. And yeah, it's the same as this one. So these things are really connected. If you found the integral, you can check it by looking for its derivative. If the derivative is same as the given, then you're safe. So that's something that I learned during the actual quiz. Many of us failed, unfortunately, because the teacher, our actual teacher, wasn't with us during the time when we were introduced to this lesson. But yeah, I think I'm understanding it now. So yeah, that's it for this video. More videos on calculus in the next one. Thank you.